Hi, my name is Ravi Ozarkar, and in this presentation, I'm going to talk about how to design your tank structure and the supporting flexible mat foundation in GT Strudel. I've divided this into three sections because it's extremely hard to talk about the whole design process in one shot. Uh, in this case, we're assuming that there are two engineers. Uh, One engineer is actually designing the support for the tank, the steel structure, and then the second engineer is designing the concrete or the substructure, which is the concrete foundation. Now, just to give you an example, okay, of a mat foundation, this could be a mat foundation. It could have a complex geometry, could have openings, it could have a tank sitting on top of it, a concrete tank or a steel tank. It can have several of these steel frames also attached to it. So on some of them, I've also designed mats with gantry cranes on top of them, so you can have moving loads on top of it too. So in the end, this type of concrete foundation needs to be designed for all these loadings and openings and stress concentrations that are going to be caused due to these openings and the loadings applied to the mat. Okay, so it is sometimes very challenging, but at the end of the day, what we're trying to do is approximate the behavior of this flexible mat foundation using finite element analysis. So things are not going to be super accurate or exact, okay? In some cases, we need to go in and round things off, and most preferably, we would like to have a nice square rectangular uh, arrangement of the mesh. But if it becomes impossible, then we would go and use other types of elements such as triangular elements. The reason why we use quadrilateral plate elements is because it's easier to interpret the results because the local coordinate system of the axis system of the finite element meshes are going in one direction, and it's easier to then interpret the results. Okay, this is the example that I'm going to be using in this presentation. Okay, it's going to be a spherical tank, slightly challenging. I'm going to be showing you how to generate this geometry from scratch using Model Wizard tool, and we're going to load this structure, analyze it, even design it, design those supporting columns and braces. We'll show you how to extract the results out to a spreadsheet and pass it to a foundation design engineer. Okay, we're going to also export the base plate positions out from this model to an Excel spreadsheet and pass it to the foundation design engineer. The foundation design engineer needs to then read those locations of those base plates and those loads and design a mat foundation shown on the right hand side. Okay, and that's going to be a flexible mat foundation supported on soil. You can also have this supported on piles, which is not going to be covered in this presentation. But there are models that are distributed with GT Strudel 41 that demonstrate that capability as well. So in the end, this is what we want to achieve. We're going to take a spherical tank, pass the support reactions to the foundation design engineer to design the mat foundation. The second part of this presentation is going to look at application of the loads on the steel structure, creating the supports, and also reviewing the results. The third part is going to concentrate on the design of the concrete mat foundation. And we're going to take a look at how seed files and groupings together can make your design process a lot more efficient. So if you have new people joining your project, They don't have to explore a lot of things. They have well documented seed files, um, a consistent naming convention for all the loadings and load combinations, so you can check their work and they can communicate with you as well. So seed files is the way to go if you're working on projects where you're going to be using a lot of load combinations over and over again. Okay, so let's dive into the presentation.